Hey everybody, I'm so excited that you're able to join me virtually today for this lesson about the weather. My name is Brandon Thorne and I'm a meteorologist for the National Weather Service. Now, two questions you may already have in your mind. One, what is a meteorologist? And two, what is the National Weather Service? Well, don't worry, I'm going to explain all of that and more for you today. As you all know, learning from home is very common for us all now. And one thing I miss most about you guys being in school is being able to come out and teach you guys about the weather. So here's a quick agenda of some of the things that we're going to talk about today. We're going to talk about what a meteorologist is, what the National Weather Service is and the role that it plays in your life. We're going to talk about some of the tools that forecasters use in order to forecast the weather. We're going to talk about why you would want to know about the weather. And we're also going to talk about some severe weather safety, including tornado safety, hail safety, and lightning safety. Now you may be wondering why I have a blow dryer in my hand, an empty bottle, and this weird rock. Well, I also have some experiments that I want to show you today using these materials, and some of these things you can do from home. So I hope that this video is both educational and fun for you as we learn about the weather together today. Okay, so first things first. What is a meteorologist? Well, a meteorologist is a scientist who studies the weather. A meteorologist is a person that tells you about the weather, and we warn you when bad weather is coming your way. There's a lot of different forms that meteorologists can take, and I think a lot of you might be thinking of your local TV meteorologists that tell you the weather, sometimes referred to as your local weatherman. But meteorologists can also work in the military, and then you can have meteorologists like myself who work more behind the scenes for the National Weather Service. And once again, there I go mentioning the National Weather Service. So, let's talk about what the National Weather Service is. We are an agency of the United States federal government that has been tasked with providing weather forecasts, warnings of hazardous weather, and other related products to different organizations and to the public for the purpose of protection, safety, and general information. The National Weather Service has 122 offices located throughout the country, split up into 6 different regions. Each weather forecast office has a geographic area of responsibility, which is known as a county warning area. And on the map here, you can see all the different county warning areas of the offices located in the United States. The National Weather Service has a sole responsibility of issuing watches and warnings for the entire country. The mission of the National Weather Service is to protect life and property, and so in order to do that, we issue those watches and warnings. Now, the question that I have for you guys, do you know which National Weather Service office covers your area? If you don't know what National Weather Service covers the area that you live in, I recommend that you take the time to find out which office. Ask your parents, ask somebody, do a Google search for it, find out which office you belong to. And then, give them a call, talk to them for a little bit, find out who they are, get to know them, talk to them about the weather. They'd be more than happy to sit there and talk to you about the weather for a little bit. Now, we know that the title of this lesson was called The Weather. So the question that I have for you now is, what exactly is the weather? If somebody were to ask you, if your parents came up to you after this lesson and said, hey, what is the weather? What is weather? How would you respond? What would you say? By definition, weather describes the state of the atmosphere at any particular time. So if you were to look out your window and you see what's going on out there right now, that's the state of the atmosphere at that particular time. Now, weather can be described in terms of temperature, precipitation, all of snow, rain, and hail. It can also be described in terms of wind speed and direction, visibility, and the amount of cloud cover that we have in the sky. So now that we know kind of what weather is, I want you to pause the video and I want you to go outside and see what the state of the atmosphere is for you guys, or see what the weather's like for you guys. I also took a look outside while you guys were doing that, and here the wind is blowing lightly, it's very warm out, and it's very humid. We have some partly cloudy skies, so ultimately I'm going to say it's warm and humid out. Now, I want to talk about some common types of weather that we might see in your neck of the woods. So I want you guys to quickly pause the video. I want you to write down some of the weather types that you think you might observe at your house. And then we'll talk about it when you come back. All right, so hopefully you were able to think about some common types of weather that you might see at your house. Here's some that I came up with. We could see anything from clouds, right? You can have partly cloudy skies, mostly cloudy skies. You can see some rain. That rain could lead to flooding. You can see thunderstorms, which always have some lightning in them. You can see sunny skies. More commonly, you can probably see some fog, snow, or cold, depending on the part of the country you live in. You have tornadoes, hail, grass fires, forest fires. You can see ice. And then strong winds can be in there too, where you can get some damage from that. So those are some common types of weather that you guys could probably see. And if I forgot anything, if you guys can think of anything, I know that hurricanes could be on there, but if you guys think of anything that I missed out on putting on this slide, go ahead and leave a comment for us and let us know what kind of weather you might be able to see. So why is it important for you to know about the weather? Why, when you wake up in the morning, why is it important for you to check the weather? So take a moment again, pause the video, and write down some reasons that you might want to know about the weather every day. So when you wake up in the morning, think, I'm going to do this. Here's why I need to know about the weather. So here are some things that I thought of. If you are traveling or doing anything like that, you might want to know what the weather is going to be like because, one, you might be traveling to a very hot or cold location. You want to make sure that you pack appropriately. So it's important to know the weather of where you're traveling to, where you're traveling from. Say you wake up in the morning to go to school or you're going to go outside and play. It's important to know what the weather's like because you have to be prepared for that, whether you're going to be in shorts that day or whether you're going to be able to wear pants or if you need a jacket. And so it's kind of important to know what the weather's going to be like every single day so you can prepare for the elements. If you're going to go to the park, you need to know if it's going to be raining. You might want to know if it's going to be windy so you can fly a kite if you're going to walk your dog. Or if you're going to go to the beach or do something like that. It's just important to make sure you know what the weather is. And the main reason that we want to know what the weather is every single day is because you really want to know how to prepare for those elements to keep you safe. Now, one of the types of weather that we saw in one of the previous slides was clouds. Have you ever been outside looking at some of the clouds? Maybe they're the big puffy ones, maybe they're the dark gloomy ones. And you really just kind of look at them and think, I really wonder how those form. Do you know how clouds form? Well, let's see if we can kind of visualize this together. I put together this next slide to kind of visualize how clouds form. As we should all know, the sun emits heat. That heat will travel down to the Earth's surface and begin to warm it up. As this happens, you will get pockets of warm air to develop along the surface. Eventually, that warm air will begin to rise up into the atmosphere. Now, the atmosphere is made up of tiny little droplets of water known as moisture. If there is enough moisture available to the air, that warm air will begin to cool, condense, and form a cloud. Okay, so now we have a general idea of how clouds form. As you can see from this cloud chart, there are many different types of clouds. On the lower level, you have clouds such as cumulus, stratocumulus, and even stratus. Some mid-level clouds like altostratus and altocumulus. And at the higher levels, you can see clouds that are known as cirrus or cirrostratus clouds. Now pause the video and with your parents' permission, see if you can identify the clouds outside using this chart. Alright, so I came outside to take a quick look at what the clouds are like out here. And as you can kind of see, we have mostly cloudy skies. Sun is definitely peeking out. But it looks like we have some cumulus, maybe stratocumulus out there. It's kind of hard to see if we have any higher clouds than that, but right now I'm going to say we have some cumulus or stratocumulus clouds. Okay, so let's switch gears here just for a minute and talk about some of the tools that meteorologists use to forecast the weather. This includes anything from our Doppler radar data to our satellite imagery that we get from our GOES satellites up in space, to our observations that we get from our automated surface observing systems, along with manual observations from volunteers scattered across the country. We also have our weather balloons that we launch twice a day. Now, weather balloons are one of my favorite things to do as a meteorologist. And you can see there on that picture on the right there, that's me before I was launching a weather balloon up in Nebraska. You can see how big they are before they launch. Now, worldwide, there are about 800 different upper air observation sites that launch weather balloons. 92 of those are owned and operated by the National Weather Service, with 69 of them in the continental United States. 13 are found in Alaska, 9 are in the Pacific, and then there's one site in Puerto Rico. Now, the balloon is launched twice a day. We use a time system called UTC time, so we launch it at 0Z and 12Z UTC. Now, how that relates is from the spring to the fall, we launch them at 6 a.m. to 6 p.m. when we're on daylight time. From the fall to the spring during the winter, we launch them at 5 a.m. and 5 p.m. when we're on standard time. Now, we don't just launch the 2 a day. Sometimes we can do additional launches as required for severe weather operations, any hurricanes that might be coming in, and even volcanic eruptions we can launch these weather balloons for. Alright, so as I mentioned, weather balloons are one of my favorite things to do while working for the National Weather Service. I love to launch weather balloons. So I showed you a picture of what a weather balloon looks like before we launch it. Here's what they actually look like before we launch it. I'll kind of stretch it up here for you to look at. Now, these weather balloons are made out of latex, and the reason for that is because they're designed to stretch to about 5 times their original size before they pop. Now, I want you guys to think for a minute what you think we might fill these with before we launch them. You might have guessed helium. You might have been thinking of your birthday balloons and helium. They make your balloons float a little bit. But we actually use hydrogen to fill these up. And the reason that we do that is because hydrogen gives us the right amount of lift that these need to rise all the way up into the atmosphere. Here's a quick time-lapse video showing the process of us filling up one of our weather balloons. As you can see, it's got a little attachment on there that helps us to regulate how much air actually flows into the balloon itself. Because like I said, we have to have a certain amount of air in order for this balloon to rise just as fast as we need it to. Now, the weather balloon itself does not actually record any meteorological data for us. And so in order for us to get that information, we have to include this device on the weather balloon. Now, this is called a radiosonde. And what this does is this helps us to measure what the weather is as it goes up and up and up into the atmosphere. Now, this was actually a radiosonde that was returned to us from the public. Somebody actually found this and sent it back to us. But let's dive in just a little bit deeper and look at all the different parts that this radiosonde has attached to it. Now, each radiosonde is equipped with a temperature sensor, which we always have at a 45-degree angle. It has a relative humidity sensor. It's got a barometer inside of the box to help to measure the pressure. And it's going to measure our wind speed and direction through the use of GPS, which is also located inside the radiosonde. Additionally, the radiosonde comes with a mailing bag that can be used to mail the radiosonde back to the National Weather Service if someone were to find it, similar to this one. Now, these radiosondes themselves are not that heavy, but if these balloons fly really high up into the sky and then they pop and this radiosonde comes falling back down to the earth, it might cause some damage if it were to hit something. And so to relieve that, we put a parachute onto the radiosonde. And this helps slow the radiosonde down just enough to where it won't cause any damage when it gets back down to earth. So imagine we have our weather balloon. The weather balloon is then attached to the parachute, and then the parachute is then attached to this radiosonde. After some calibration between the radiosonde and the computer, it's time for liftoff. Now, this is one of my favorite parts, watching the balloon get smaller and smaller as it rises into the atmosphere. Here's a few more fun, interesting facts about weather balloons. The flights last about 2 hours long, and that's just the amount of time that we track them. Weather balloons can reach heights of just over 20 miles long, or about 100,000 feet up into the air. They can travel up to 250 miles per hour, and they can drift as far as 125 miles away from the office location. And as I mentioned earlier, the balloons can expand to about 5 times the initial size, which is just about the size of a school bus. Now, one question we always get when we present information about the weather balloons is how we get the data from the radiosondes. Because we send these radiosondes up into the sky, they travel for about 125 miles away from the office. How do we get that data back? Well, as the weather balloon travels up, it sends data in real time back to our upper air buildings. There's a big antenna there on top of the upper air building, which actually receives the information from the radiosonde. Once it receives the information from the radiosonde, it then transmits it back to our office to a computer there. That computer then takes all the information and presents to us what is called a skew-T diagram. It gives us all the information in real time so that we can see it. Now, a skew-T sounding gives us a vertical profile of the temperature and dew point temperature throughout the troposphere and the lower stratosphere. It is designed to help paint a picture of what the air is doing above us. It's important for us to know what's going on above us because it helps us to make a forecast for what's going on at the surface. The skew-T soundings are a vital piece of information that help us make a really good forecast. So check out this cool photo time-lapse video of a weather balloon rising to around 104,000 feet over Oklahoma. Now you can really start to see the curvature of the earth a little bit before it pops and falls back down into a farmer's field. I really enjoy that video because it shows just how high these balloons fly before they pop. Now let's check out this awesome video showing a weather balloon popping at around 100,000 feet as seen through a telescope taken back in 2014 over Stonewall, Louisiana. The balloon at this moment is around 20 to 25 feet in diameter before it pops. It's amazing to see how many different pieces the balloon breaks into. And now you can see the radiosonde and the parachute begin their descent back to Earth. Another great tool the meteorologists use on a regular basis is a Doppler radar, which we call a WSR-88D. This radar is one of the most powerful and advanced weather surveillance Doppler radars in the world. There are around 160 different locations across the United States that have a Doppler radar. We use this tool to watch and interrogate thunderstorms from the point that they develop until they dissipate and are no longer a threat. The radars produce a number of different products such as reflectivity, which show us how much precipitation or how hard the rain might be falling in a storm. Our velocity products, which show us how fast the particles in the air, the rain or the snow, are moving relative to the radar. The green indicates that the particles are moving towards the radar, while the reds indicate that the particles are moving away from the radar. Then we have our correlation coefficient tool, which can help us decipher the difference between meteorological returns, such as rain, snow, or hail, and then non-meteorological returns, such as birds or leaves that might be blowing in the air. We use all of these tools to find out how severe a storm will become. How does it all work, you might ask? Well, the basics of the radar is that a beam of energy, known as radio waves, shoot out from a large antenna located at the top of the radar. As these beams of energy strike objects in the atmosphere, the energy is scattered in all directions, with some of the energy returning back to the radar. This antenna will spin around in a full circle at a number of different elevations, giving us a new full look at a storm every 5 to 6 minutes. Okay, so now that we talked about some tools that meteorologists use to forecast the weather, let's talk about some forecasting basics. So the air above us is very fluid. It is similar to that of the ocean, meaning that it is continually moving and changing around the world. Our job as a National Weather Service forecaster is to determine what the flow will do over time and how it will affect us. Imagine throwing a leaf into a river. Our job is to find out where that leaf is going to go and the impact that it's going to have as it travels down the river. As I mentioned earlier, the air is continually moving above us. Now, some of the areas that are constantly moving are that of high and low pressure systems. Now, high pressure systems spin in an outward clockwise flow, and the air underneath the high pressure descends down towards the ground. These type of systems are typically associated with good weather. Now low pressure systems, on the other hand, spin in the opposite direction, which is a counterclockwise flow, and the air will rise up towards the sky. Low pressure systems are typically associated with bad weather. Okay, so to produce clouds and eventually get some sort of precipitation, the atmosphere needs three key ingredients. The first one is lift. We need some sort of way to lift the air up into the atmosphere. The next ingredient is instability. Now, the way I like to think of instability is to imagine a beach ball being suspended at the bottom of a pool. If you were to let that ball go, what's going to happen? Well, it's going to quickly rise to the surface of the pool and even pop out of the water a little bit. The last thing that we need, which we've already mentioned, is that of moisture, which is going to help develop our clouds. Frontal boundaries are a way to provide lift to the air. There are two types of fronts that I want to talk about, and the first one is a cold front. A cold front is a boundary separating an advancing mass of cold air. As you can see from the diagram, the cold air, as it advances towards the warmer air, when the cold air meets that warm air, the warm air is going to be forced up and over the cold air. As it does this, the air begins to cool, condense, and form a cloud, which will then lead to the potential for thunderstorm development. The other common frontal boundary is a warm front, which is a boundary of an advancing mass of warm air. As the warm air begins to overtake the cold air, the warm air is forced up and over the cold air, creating precipitation into the colder air mass. Oftentimes, cold fronts and warm fronts are both associated with a low pressure system. Okay, so now that we've established some forecasting basics and we know that an advancing cold front can produce thunderstorms, let's talk a little bit about thunderstorms, severe weather, and then some severe weather safety. Thunderstorms can be a very exciting thing to watch for me. I love to watch lightning off in the distance, but I don't so much like it when thunderstorms move overhead. And the reason for that is because they can be very dangerous as well, producing large hail, damaging winds, and even sometimes tornadoes. Now this here is a very conceptual picture of what a classic supercell might look like. Some of the features that you may see here are the towering cumulonimbus cloud there in the middle. Now all supercells and thunderstorms have what's called an updraft or a mesocyclone. Now this is the warm air that is rising rapidly up into the atmosphere. At the top there you'll see what's called an anvil. As the air is rising so rapidly up into the atmosphere, it reaches the bottom of the stratosphere. As it does this, it has nowhere else to go but out, and so it begins to expand and spread out away from that updraft. Now you may be wondering what that overshooting top is then, if the anvil is the bottom of the stratosphere. To imagine the overshooting top, let's go back to the analogy of the ball in the pool. As that ball begins to rise up to the surface of the pool, sometimes it shoots over a little bit because there's so much pressure pushing on it up that it shoots out and over the top a little bit. That's exactly what's happening here. You have your rising air, when it hits the stratosphere, sometimes if you have a strong enough updraft, it'll actually push up above portions of the stratosphere and create that overshooting top. Now some of the additional features that you see in the thunderstorms are the flanking line, which are off to the back. They're basically new updrafts that are forming. Some supercells will produce wall clouds or even tornadoes. And then off to the right there on the picture you can see the area of the storm where you have rain and even sometimes hail, which is a part of the downdraft of the storm. Okay, so let's move on to one of my favorite subjects, tornadoes. I know it seems like a very odd thing to be excited about, but tornadoes are one of the things that I've always studied and have been very fond and scared of at the same time, but their power is just so amazing. So through my years I've been able to do some storm chasing, and these are some pictures that I've been able to capture of some tornadoes. One in Perryton, Texas, one in Dodge City, Kansas, and then El Reno, Oklahoma back in 2013. Well, first things first, what is a tornado? By definition, a tornado is a violently rotating column of air that extends from a thunderstorm to the ground. The strongest tornadoes can cause tremendous destruction with wind speeds up to 300 miles per hour. There's a lot of different factors that play a major role in the formation of tornadoes, but for this presentation we're going to focus on the updraft. Okay, so we've talked about tornadoes, we've talked about thunderstorms, and we've talked about updrafts. So let's try to tie all that together now. We're going to focus a little bit on updrafts with this simulation here. Now you may be wondering what all this stuff is. First things I want to talk about is this. Remember the bottles that I showed you earlier? Well, this is something that you can do at home to make a tornado in your own home. It takes two big bottles, Now you do have to find a little piece that is attached to both bottles that you can find on the internet. But once you have all those, you just fill it with some water. I put some dye in this one just to turn it a little bit a different color so you could probably see it a little bit better. So what you do with this is once you get it all together, you just turn it upside down. You kind of turn it like this, and you'll see a tornado form there. Now it's a quick and easy thing just to kind of show that it's just a tornado in a bottle. There's nothing special with it. There's no real science behind it other than it's kind of doing what it does when you flush the toilet or when you see water go down the drain in the bathtub. So this is something that you can try at home. Now also online you can find these little pet tornadoes is what they're called. These things are really cool. And all you have to do is spin them really quickly and it'll create a tornado. So this is a way you can bring a tornado to your home and bring it to life. These are really fun. I let my kids play with them all the time. And they can make their own little tornadoes, you can see there. Now let's talk about the bigger thing here. This is a teaching tornado machine. Now, what we have with most thunderstorms, as we talked about, is an updraft. That updraft is what's very vital in order for a tornado to form. Now what we're doing here with this teaching tornado is we're making some rotation at the surface of the earth. Basically, part of tornado genesis, the way that it happens, is you get some kind of rotation in the atmosphere. When you get an updraft of a thunderstorm to move over that rotation on the ground or on the surface or in the air, it begins to pull that air up into the storm. The updraft will suck it up, and as that column of air begins to stretch, it'll begin to form a tornado. And so let's give this an updraft, and we should start to see a tornado form from this. So there you have it. We've made a tornado in our home, and you guys have some experiments that you can try at home yourself. Alright, so hopefully you enjoyed that experiment on making a tornado at home. So back at our office, we have a larger tornado machine similar to the one that I showed you here today. Take a moment and look at the video of this tornado machine. Now, let's talk some tornado safety. What should you do if a tornado warning is issued for your home? Your best options for tornado safety are in this order. In an underground storm shelter, storm cellar, basement, or engineered safe room designed to withstand a tornado. On the lowest floor of a sturdy building, stay away from doors, windows, and outside walls. The main thing here, you want to put as many walls between you and a tornado as possible. Use pillows, couch cushions, sleeping bags, a mattress, or even blankets to cover up. If you have a helmet, a bicycle helmet, a hockey helmet, a football helmet, make sure to wear them. Now some other important sheltering reminders. Make sure that if you have a cell phone that it's charged at all times, and take your charger with you to the shelter or safe room. Make sure you know what to do with any pets that you might have. Now this thing is something that you can remember to say duck. So the D, go down to the lowest level. The U, get under something sturdy. The C, cover your head. And the K, keep in the shelter until the storm passes. A good way to do this is to do what's on the picture there. That's a really good diagram of something you can do during a tornado. The main thing with this is you want to make sure you know where your safe place is. And if you don't know where your safe place is at home, I want you to pause the video and go and ask your parents where your safe place is in case of a tornado. Now, even if you don't feel like you get tornadoes in your neck of the woods, still have a plan in place just in case. Okay, so not all thunderstorms will produce tornadoes. As a matter of fact, most thunderstorms are not going to produce one at all. That being said, most of them will produce small or large hail, strong winds that could potentially cause damage, lightning, and heavy rain. Have you ever seen a hailstone at your house? Hopefully it wasn't that big and didn't cause any damage. Hail is a form of precipitation consisting of solid ice that forms inside of a thunderstorm's updraft. Okay, we've talked about thunderstorms and now we're talking about hail inside of a thunderstorm. Now, we've also mentioned updrafts again. Remember earlier when I brought in this blow dryer and said we were going to use it at some point during the presentation? Well, now's that chance. And it's not just for me to do my hair, although I can definitely do that. No, if you have a blow dryer at home and a ping pong ball, you can do this experiment with me. So what you're going to do is you're going to grab the blow dryer, put it on its cool setting if it has one, and then you're going to point it straight up into the air like this. What you're going to do is when you turn it on, you're going to take the ping pong ball, you're going to hold it into the blowing air, and you're going to release it. Now I want you to think for a second, what do you think is going to happen to the ping pong ball? Is it going to blow up into the ceiling? Is it going to fall off to the side and I'm going to have to pick it up? Well, let's find out. I'm going to turn it on and show you. Voila! It floats! Alright, so you may be wondering, how does this magical floating ball relate to hailstorms? Well, rain and hail will be suspended by an updraft inside of a thunderstorm until the weight of the hail and water can no longer be supported. At that time, the hail will fall from the sky. Typically, the stronger the updraft, the larger the hail will be. The air coming from the blow dryer is simulating that of an updraft and keeping the ball in the air. It has basically reached a point where the amount of gravity pushing down on the ball and the amount of air blowing up from the hairdryer are equal. Okay, but that's not all that's happening here. How come the ball isn't falling off to one side or the other? Remember earlier we talked about the difference between high and low pressure? Well, the ping pong ball remains in the stream of air due to lower pressure created around the surface of the ball. This effect is called the Bernoulli principle, named after Daniel Bernoulli, who was an 18th century Swiss scientist who discovered that as the velocity of a fluid increases, its pressure will decrease. Now, this principle can be best seen through a venturi tube, which is narrower in the middle than on the ends. When fluid passing through the tube reaches the narrow part, it speeds up, and according to Bernoulli's principle, it should exert less pressure. The low pressure effect can also be seen around the ping pong ball in a different way. The narrowing now takes place around the perimeter of the ping pong ball, and as a result, there is an area of low pressure immediately adjacent to the ball. So we've talked about a few things that thunderstorms can produce, from tornadoes to hail. One thing that all thunderstorms will produce is lightning. It can't be called a thunderstorm without thunder, and you can't have thunder without the lightning. Now, watching and listening to a thunderstorm can be very exciting, or even relaxing to some. But you wouldn't want to be out in it because lightning is very dangerous. Lightning happens when ice particles in the cloud collide with one another. This creates an electrical charge, and when this charge connects with electrical charges on or near the ground, you get a lightning strike. Lightning is extremely dangerous and can travel up to 10 to 15 miles away from a thunderstorm. So if you happen to be outside, it is important to make sure you go inside during a thunderstorm. We have a really fun saying that you can all say at home: when thunder roars, go indoors. It's important to remember this because if you are outside and you can hear thunder off in the distance, you are close enough to be struck by lightning. So make sure to go inside if you see or hear a thunderstorm moving in. Now, when you're inside, some best practices during a thunderstorm: make sure you stay away from windows and try not to take a shower or a bath. We don't want you to end up like this coyote. So we've been talking a little bit about lightning. Remember earlier I showed you this rock? Well, this isn't just any ordinary rock. This is actually called a fulgurite. Now, the word fulgurite comes from a Latin word called fulgur, which means lightning. Fulgurites are natural tubes, clumps, or masses of fused soil, sand, rock, or organic debris that sometimes form when lightning discharges into the ground. When the lightning hits the ground, it basically vaporizes and melts all the items together, which can create these fulgurites. Alright, you guys, thank you so much for joining us again here virtually for this lesson about the weather. I hope it was fun, I hope it was educational, and I hope you were able to try some of those experiments that we tried. Now, if you have any comments, feel free to message us below. We'd be happy to answer anything that you have. And most importantly, the last thing I want to leave you with is this. If you guys have a NOAA weather radio at home, great. If not, I highly recommend that you get one. These truly do save lives. If you enjoyed this presentation and love the weather and want to learn more about it, here's some links to get you started.